Going well, sir.
How are you feeling about work power energy chapter?
So far, I understood everything.
Okay. Comparing with previous two chapters, how is it?
I felt like it was a little easier when I was doing the questions.
Oh, you started doing questions?
Yes, sir. I have a small doubt.
Yes, please.
I'll send you the picture of the question. I
Yes, send me in the WhatsApp.
I got the answer 3, but in the answer key it says option 2. I'm not sure why.
Send me quickly. Discuss, okay? One small doubt you don't leave, you discuss, okay?
Okay, sir.
We are not going to keep any doubts. Hi, Samhita ma'am.
Good evening, sir.
Good evening, madam. A body of mass 2 kg is subjected to a force which varies with distance as shown in the figure. Okay, force versus distance diagram is given, no?
Yes, sir. I got option 3.
Let me see now once. So then this. Okay. This is how much? 3. This is 6. This is 9. Okay. This is how much? 20 Newton. Huh? Okay. X is in meter. Mass is how much? 2.4 kg. Okay. Okay, its velocity at x is equal to 9 meter is. They are asking velocity at 9 meter, right?
Yes,
So
sir.
what is work done? Work done is integral f dx, right? Correct?
Yes, sir.
And that is nothing but change in kinetic energy. Correct? So
Yes, sir.
area under a force distance graph gives you work. Okay. So calculate the area. First half into base is 3, height is 20, plus this is how much? This distance will be 3, this 20. So 20 into 3, 60, plus half into this triangle. 9 minus 6 is 3, height is 20. So 10, 30 plus 30, 60 plus 60, 120. So this is your work, right? So work is equal to final kinetic energy minus initial kinetic energy. So at initially, if you see, the body is starting at x equal to 0, correct? What is the
Yes, sir.
force acceleration there? 0, correct? And x is also 0, correct? No, that means initial velocity is 0. So 120 is equal to half mv square. So this is final velocity at x equal to 9. Okay. So you do this 120 into 2 divided by mass is how much? 2.4. So from here you calculate 1.2. So you write one more 0 here. So 12 on the 100. So yeah, it is 10, no? 10 meter per second.
Okay, sir. I guess the answer key is wrong.
Yeah, I think that is wrong. Okay.
Sir,
Yes.
sir, I actually was doing PYQs of loss of motion yesterday, sir.
Okay.
I got it out, sir.
Yeah, please ask me.
Sir, the question is a heavy iron bar of weight 12 kg is having its one end on the ground and other end on the shoulder of a man.
Okay, so there is a man and there is a heavy iron block. Okay, like this, right?
Yes, sir, and it makes 60 degrees angle with the horizontal.
Okay,
The weight experienced by the man is
the weight experienced by the
man.
okay. So what? How did you try this?
So I took normal at shoulder, sir. I got mg cos I did it equal to mg cos theta.
See, anyhow, this bar will be putting how it is putting mass, how it is acting force along normal only, right?
Yes, sir.
Correct. So first you draw free body diagram of this bar. So here normal will be acting like this, right? And mg is acting like this. Correct? No?
Yes, sir.
Correct. And then the man will be applying one normal reaction like this. Am I correct, Samita?
So how is it in the direction of the rods?
See, because the man and the rod are connected like this, right? So this bar will exert a normal on man like this, and man will exert a normal on the bar like this. Correct, no?
Understood.
Now you can solve, or shall I help?
I'll solve.
Okay. So this component he will experience. Correct, no?
Yes, sir.
So it's a good question, huh? From where you brought it?
So it's 27th second shift, sir. 2024 minutes.
Yeah, it's a good question. Try it out. Let us see what answer we get. You know the answer, right?
Yes, sir.
Okay, so see, if I resolve this normal, let's say this is n1, okay? So this will be how much? N1, this is 90 degrees, so this will be 30 degree, correct? So n1 cos 30 degree, and like this we have n1 sine 30 degree, correct, no? And can you tell me there is a friction or not?
No, sir, they haven't given anything about friction.
Okay, so if it is resting on the ground, that means there has to be friction. Okay, so this rod has a tendency of slipping this side, so friction will act this side. So friction will be balanced by n1 sine 30 degree. Okay, so and then in vertical direction, you have to write n is equal to n1 cos 30 degree plus mg. Correct? No. And now if you see the man, so the normal is like this. Normal on him is like this, and this is a 60 degree. Correct? No. Yeah, so this line is making 60 degree angle with horizon. Okay, and mass mg he will experience like this. So from here normal from ground will come like this, correct? No, let's say n2. So again two components. From here you can say that n2 is equal to mg, and here you have to add n1 sine 30 degree, correct? No. From here you have to calculate this. You have two unknowns n1 and n2, correct? And you have two equations. You solve and get what is the value of this n1, okay? And your answer will be n1 cos 30 degree. Okay,
Yes, sir.
yeah. Any other doubts you guys have? You can take a screenshot if you want, Samita.
Yes.
Okay. Any
Sir,
other
once can you
doubts?
show it?
Yeah.
Once can you show the screen, sir, that answer?
Oh my god, wait, okay, it came.
Done, sir.
Okay. So what is the answer given?
3 kg.
So you didn't tell me what is the mass of this bar and this man.
Oh, so they haven't given anything. The what I've said in the question, only that information is given.
What is the question? Can you read again?
Yes, sir.
Hmm. Can you read it again?
The a block of iron bar of weight 12 kg.
Hmm.
A
See,
heavy
given
item.
no. 12 kg
Heavy.
is given no.
Yes, sir.
Then so from there only you calculate, you'll get 3 kg. Okay.
Yes, sir.
Okay. Simple. So let us. No doubt, right? Shall I proceed with the class? Everyone joined. Let me see. No other doubts, right? So, guys, you have to ask doubt like this. Okay. So good. I was happy that you are asking doubts. So every day it should be like this. Okay, let us proceed. So we were talking about work, power, and energy, and we started with work. Correct? Guys, tell me what is the basic formula for work? Anyone can tell fast.
F dot S.
So that is for constant force. Okay. F dot ds, not F dot S. Change in position, right? And then for variable force, what is the formula, Samita?
So F bar, integral of F bar dot S.
Very good. Okay. So, all right. So this much we can you tell me work energy theorem, Xavier? Xavier, are you there, man? Xavier is there, no? Yeah. So what is your problem? Why are you not speaking? Mike is having a issue. Okay. So you fix it. Okay. Tomorrow onwards, you have to speak. Yeah, Shreyata, tell me what is work energy theorem?
Half m into v2 square minus v1 square.
Yeah, so work done is equal to change in kinetic energy. Tell like that. Okay. Final kinetic energy minus initial. All right. So now in Newton's laws of motion, we forgot one concept, pseudo force. Okay. PSUDO. Pseudo force. Okay. So what is pseudo force means? The Newton's laws are there. No, whatever we are applying. Newton's laws. F is equal to ma. All these things are valid when the frame is not accelerated. Okay. So like we are observing the motions on earth, right? We assume that earth is not accelerated. Okay. It is a fixed frame. It is not at all moving, or like it's not having an acceleration. We ignore the effect of, though earth is rotating, there is some acceleration, but we ignore all those things. And we say that, well, earth is not accelerated and it is a frame of reference. From there only you can apply Newton's laws. Otherwise, for example, let us say I will tell you a lift problem. For example, a lift is going up, okay, with an acceleration a. Okay, let's say one person is sitting on the ground and one person sitting in the lift. Okay, let us say there is a block inside here. So if I ask this man outside who is sitting on the ground what is the acceleration of this block M? What he will say? Shreya?
Sir, A.
A, right? So he will say that this block is moving up with acceleration A. So if you ask this man inside who is sitting inside Samhita, what he will say? What is its acceleration?
Sir, A, sir.
No, right? Because see, he will say this is at rest, correct? Because he is also moving with A, no?
Sir, I didn't hear the question properly. You asked the man's acceleration or
See, there are two mans, okay? One is sitting inside the lift, one is sitting on the ground outside, okay?
yes, sir.
So now if and this lift is moving up with an acceleration A,
Yes,
okay?
sir.
Then if I ask the person who is sitting on the ground, what is the acceleration of this block, which is inside the lift? So he will say it is A, correct?
Yes, sir.
If you ask a person who is sitting inside the lift, what he will say, this block is at rest, right?
Yes.
Yeah. So how you are saying it is at rest? So then if you want to explain that with Newton's laws, then we have to apply a false force, okay? That means it doesn't exist, but to make things simpler, we use the false force. So how to do that? So for that, formula is pseudo force is equal to mass of the object into acceleration of the object in the opposite direction. Okay, A should be in opposite direction. Okay, so that means you have to apply a reverse force on this mass of the object into acceleration of the object, correct? So now since mg is acting downwards, correct? So now he will you have to say that, well, so this block is having an acceleration of a plus g, okay? And if the lift is going down, then you have to say that the block is moving with acceleration of a minus g, okay? If it is moving up, then you have to add. If it is moving down, you have to subtract. Okay, guys? So we'll take different cases, then you have to tell me what is the work done in each case. Simple logic you have to use, that the work is equal to force into displacement. Okay, guys? One more thing I want to tell you, that in F is equal work, W is equal to F dot S. Okay, this displacement is of point of application of force. Okay, so what does that mean? So for example, let us say there is this block, okay, of length L, okay? So and a mass M. Let us say I will apply force of 10 Newton, and I will, one second. Are you able to see my screen?
Yes, sir.
Okay, all right.
Yes, sir.
So let us say I will displace it by 10 meter. Okay, and this length, let me take 1 meter. So now the block is here. Guys, tell me what is the work done? Come on.
100.
10 is the force. What is the displacement?
10.
See, observe carefully. Displacement is of point of application of force. So you have to see where the force is applied at this point. So you have to see the displacement of this point. Okay, so this point has moved how much?
11 meters.
Yeah, 10 plus 1. These people have confusion. Okay, 10 if you keep, marks gone. 11 you have to put. So it is 110 joule. Okay, guys. Any doubt?
No, sir.
Yeah. So note this, take screenshot or note it down. I'll take screenshot and you can write it later because we need to move little bit faster. There are many things, many chapters we need to cover, right? When is JEE exam next?
Sir, I got my date on 9th April.
No, 9th April.
Yes,
So
sir.
mine is on 8th, sir.
Anybody else is giving? Others, Samhita?
So 8th, sir.
Okay. All right, no problem. So guys, let us say now there is a man who is pushing a block, okay? So let us say there is this cart. So let us say this comes here. Okay, the cart comes here. Now man is here. And let's say this distance is S0 and this distance is S. Okay. So guys, can you tell me, let's say the man is pushing the block with a force F. Okay, tell me the work done by the man or work done by this force F. Quickly. How much the block has displaced? See, this point you have to see. The man is applying the force here, no?
S
So
not, sir.
it didn't move just S0. It covered S also, no?
Okay, I thought it just moved from the other side.
No. So he covered, you have to see how much distance it has covered. So it will be F into S0 plus S. Okay. But if you ask this man who is sitting inside the trolley, what is the distance this block has moved, then it is S0, correct? So from the ground, you will see this much work has been done. But if you ask this man, he will say it has moved only S0 distance, correct? Then work done from inside is how much? F into S0. So work is a frame dependent. Work is frame dependent. From where you are seeing, that is important. Work is frame dependent because displacement is also frame dependent. So from from where you are seeing, that is important, right? Both man and block has covered S, but they don't, feel that. But someone who is sitting outside will say that, well, this block has covered a total S0 plus S. So from where, if nothing is mentioned, you have to consider everything from ground, okay? Please take the screenshot. Okay, all right. So let me give you one more question. Let us say there is a block of mass M and tension T. There is a rope I have connected and I'm moving it a height H. Okay. Can you tell me work done by tension? Can you guys tell me work done by tension? Tell me, Shreita.
Sir, is it MGH?
Why are you going to MGH? When I say tension, that means force is my tension. Displacement is H. T into H is the answer. See, work, which force I am telling you have to see only that force and displacement. If I ask what is the work done by gravity, then you have to say, okay, mg. mg is acting downwards. Oh, displacement is upwards. So you have to write minus mgh. If they are opposite, you have to put minus. If they are on same, tension is also upward, displacement is also upward. That's why it is plus th. Okay, any doubt here?
No, sir.
Okay, all right. Let us say there is a block here. Okay, and now I am pulling it with force F. Okay, and the friction on it is, let's say, F. So can you guys tell me, if I move it by distance S, what will be work done by force F? It will be F into S. What will be the work done by friction? Minus F into S. Okay,
Sir, how about total work done?
you add it. It is just scalar quantity, no? It is like numbers. You
We can
add
just
it.
add it, right? Yeah.
Total work done is work done by F plus work done by friction plus work done by normal. But work done by normal is 0 because normal and displacement are perpendicular. So when theta equal to 90 degree, so that will be 0. First, you see if they are asking total work done, consider each force and calculate separately and then add. Okay. Taken screenshot.
Yes, sir.
All right. So let us do one practical question. Let us say I am applying a force of 10 Newton. Friction coefficient is 0.5. Mass is 2 kg. So tell me what is work done by F, what is work done by friction, and what is total work done. One by one, each one of you have to tell. Samhita, tell me what is work done by force. First, what we have to do? First, we have to check whether this block will move or not. So what is the maximum friction value? Mu into N, correct? Mu is 0.5. N is mg, that is 20. So this you cancel. 5 to the 10 Newton. So exactly it is balancing, right? 10 Newton. So work done by F is also 0. Work done by friction is also 0. Total work done is also 0. Okay, because the block is not moving. Since the block is not moving. Any doubt here?
No, sir.
Okay. So let us do the same thing. 2 kg mass, friction coefficient 0.5, force I am applying 12 Newton. Okay. So there is, we have to calculate what is the work done. If I move this block by 2 meter, okay. If I move it by 2 meter, you have to tell me what is work done by F, work done by friction, and work done by total work done. Tell me, guys. So here block will move, right? Because maximum static friction will be 10 Newton. It comes out to be 10 Newton. We calculated just before. So 12 Newton is more than 10 Newton. So it will move. So work done by F will be 12 into
24.
2, 24 joule. What will be work done by friction?
Minus 20.
Yes, minus 10 into 2, minus 20 joule. What will be the total work done? 4 joules.
4.
Okay, very good. Let us do more. All right. So let us say we have an inclined plane. Okay. Theta angle. Let's say I'll give 37 degree. And there is this block. Okay. So, and let's say the coefficient of friction there is 0.5. Again, mass is 2 kg for simplicity. And this length is 3, this length is 4. So this length will be automatically becomes 5. So now the question is, you have to draw the free body diagram. So here this component will be how much? Mg sine theta. Correct? This component will be mg cos theta. Correct? No? This will be normal and this will be your friction. Correct? First you need to draw these 4 forces. Okay. So guys, tell me what will be the, first you have to check whether this block moves or not. For this block to move, the mg sine theta should be more than the maximum value of friction. So friction maximum value will be how much? N into mu. So mu is 0.5. Normal will be mg cos theta, because these two will be balanced, right? M is 2 kg, G is 10, cos 37 is 4 by 5. So 5 ones are 5 twos are 2 twos are 4, 4 fours are 16, 16 fives are 80, right? 8 Newton is coming, correct? 16 into 5 is how much, guys? 80, right? 8 Newton is coming. Now I have to check mg sine theta, how much it is coming. So the gravitational component force, that is mg sine theta, m is 2 kg, g is 10, sine 37 is 3 by 5. 5 2s are 2 2s are 4, 4 3s are 12 Newton it is coming. So 12 Newton is greater than 8 Newton, of course it will move. So work done by gravity will be how much, guys? The force is mg sine theta, correct? Along the direction of motion you have to see. Along the plane it is moving, right? Correct? So here it is moving like this. So the gravitational force is mg sine theta into what is the displacement? 5 Newton, 5 meter. From here this is 12 into 5, 60 joule. Can you tell me what is work done by friction? Friction force we calculated 8 into displacement 5 with negative sign, minus 40 joule. So here total work done will be 20 joule. Any doubt in this question? Any doubt?
No, sir.
No doubt? No doubt, guys?
No, sir.
Okay, all right. So now you guys tell me, this thing we have studied, right, in Newton's laws of motion. This is 2 kg, this is 4 kg. So here we have to calculate the work done by tension. Total work done by tension will be 0, right? So from here it will do positive work done, and then from here it will do negative work done. So total tension will be 0. But if I ask what is the work done by tension on this 4 kg, so how will you say that? Well, so let's say this is moving down and this is moving up. So we need to calculate first what is the acceleration. Supporting force is 40 kg, right? 40 Newton. Opposing force is 20 Newton. Divided by total mass 4 plus 2, 6. 40 minus 20 is 20 by 6. 10 by 3 meter per second square. This is my acceleration. Okay. We need to calculate tension. You write equation for any one of. I will write for 4 kg. Okay. Tension is upwards, mg is downwards. correct? Supporting force is 40, opposing force is tension, is equal to mass into acceleration 10 by 3. So 40 by 3. So from here, tension is equal to 40 minus 40 by 3. That is 120 minus 40 by 3. That is 80 by 3. Correct? So we have tension, and they said that, okay, so this block is going down in 2 meter. How much is the work done? Work is done. So work done by tension on 4 kg will be 80 by 3 into 2 meter. This will be 160 by 3 joule. Similarly, on 2 kg, see again it will be negative because tension is upwards and the block is moving downwards. So I have to keep a negative sign. Please remember. On 2 kg, the block is also moving up, tension is also up. That means the positive work done. So on 2 kg by tension, it will be how much, guys? How much it will be? 80 by 3 is my tension multiplied by 2. So distance is 2, right? So 160 by 3. This will be plus C. The total work done by tension is coming out to be 0. This is plus 160 by 3 minus 160. Okay. Any doubt? Any doubt, guys?
No, sir.
No doubt? No doubt? So let us see some
No,
previous.
sir.
Let us see some previous year questions then. Okay. On based on work. Tomorrow I will start class 12 to one chapter parallelly. Okay. On Sundays we have to cover 2 days. We'll cover class 12 and 2 days, 3 remaining days class 11. Okay. Class 12 is very important. Tomorrow you all join, right?
Yes, sir.
Or you have any plan? Okay, so are you guys able to see my screen?
No, sir.
Xavier
It's
is
not.
here back, huh? Xavier,
Yes,
you are
I changed it.
okay. So are you able to see now?
Yes, sir. Able to see now.
Okay,
So
let us
tomorrow,
try.
what time, sir? Do we have class?
What? Tomorrow?
Tomorrow, what time do we have class?
Oh, so when are you free? I'll schedule based on that.
There is the
So,
morning again.
What?
The morning.
Morning, I am busy, but I can take around 12. Is that fine?
so I will probably be in church. So, like, I have service, Easter service that time.
Okay, so you guys decide and tell me, okay, what will be the proper time.
Okay, sir.
Body of mass 2 kg begins to move under the action of a time-dependent force given by this. The power developed by the force at the time t is given by. Power I have not taught you yet, right? Leave it. Yeah, come here. Second question, guys. Block of mass 1 kg is pushed up a surface. Read it, try it once. Tell me the answer. Guys, try this up. Mass of block is given, break it into component mg sin theta, mg cos theta. Okay. And they have given one 10 Newton extra force also. They are asking how much work is being done against the friction. What does that mean? Who is doing the work done against friction? Tell me, guys. Friction is acting down or up? Anybody please confirm? Friction is
Sir,
acting
it's
down or up?
acting down.
Yeah, friction is acting down. Mg sin theta is acting down or up?
Up.
Hey, mg sin theta, amma.
It's down also.
Down. So mg sin theta and friction both are in same direction. So mg sin theta is not doing work against friction. So the only force which is doing work against friction is the 10 Newton, and the displacement is given 10 meter. Simply you multiply 10 Newton by 10 meter.
So is the answer 5J, option B.
5 joule. Work done against friction force mu into n into 10. So this is mu is 0.1, normal is 5, displacement is 10. See, this is work done by the friction, right?
Yes, sir.
Work done against friction they are asking. It should be
It's
10.
against only, no?
Well, okay, I got it. So this much positive work we have to do. So work done by friction is negative minus 5 joule. So you have to do plus 5 joule against it, correct? If you want to cancel it out.
Yes, sir.
Yeah, so minus 5 joule will be work done by friction. You just put a plus sign, then it becomes against friction. All right. So stack gently push down to the right. Speed of the ball and reaches the point B is. Okay. So guys, tell me how can you solve this? When it is at A, what is its energy? How much is the like work done by gravity? Mg into 1, right? Correct? Let me share you my screen and explain. I will teach, there is like potential energy thing we have to study. So, but without that also you can do. We have kept one block here, right, at a point A, 1 meter height, correct? Now we are bringing it at 0.5 meter height, correct? So now when it comes from A to B, guys, what is this displacement? 0.5 meter, correct? So what is the responsible force which is taking it down? The gravity. So gravitational force is also down and displacement is also down. Mg into 0.5, and this should be equal to the change in kinetic energy, m into v final square minus half m into v initial square. Initial is 0. We just released it. Final I want to calculate. M got cancelled out. G is how much? 10. Or you can say how much they have given in the question. G, how much they said to consider. G is equal to 10. So can you do it?
So
Simple,
root
right?
10, sir.
G is 10.5
Root
into
20.
2
Yeah.
root is VF. So it is 1. So root 10, no, it is coming. Root 10 it is coming, right? Mass is 1 kg given, right?
Yes, sir.
So root 10 we are getting. Let us check the answer. Yeah, root 10. Okay, guys. So far, whatever I have taught, that is only coming. Yeah, yes, see this question. A bob of mass m is suspended by a light string of length L. It is imparted a minimum horizontal velocity at the lowest point A such that it just completes half circle, reaching the topmost point B. Okay. The ratio of kinetic energy Ke at A to Ke at B is. Okay. So let me share my screen again. So what we are doing, see, people teach these concepts separately, okay, vertical circular motion and all. But if you have basic idea of work done, that is enough. See, what we are doing, we are sending it with a minimum speed such that it reaches the top point. This is point A, this is point B. If somehow I reach it here, automatically it comes down, right? No need to push it further. Correct? Correct, guys? So even if the velocity here it becomes 0, then also it will come fall, continues the circle because of the gravity. So just our job is to reach the point B. Okay. Then what should be the minimum velocity? You write. Okay. Work done will be how much? Work done will be mg into whatever this height is, the radius, 2 times r. Correct? To 2 times r. This is equal to change in kinetic energy. Final this, because the displacement is going up and the gravity is acting down, so it will be negative. Final kinetic energy, since it's just reaching the top, so 0 minus half initial velocity mv minimum square. So from here, what you are getting? From here, how much you are getting? See, what is the v value you are getting? Minus mm got cancelled out. So it is 2 to the 4 into g into r under root. So this should be the minimum speed you should throw so that it will reach the topmost point or it completes the circle. Any doubt here, guys?
No, sir.
Simple, right? Simple maths I'm applying. Now what he is saying, let us see. In the question, what he is saying, it is imparted a minimum horizontal velocity at the lowest points A such that it just completes half circle reaching the topmost position B. Okay, the ratio of kinetic energy of A to B is at B, this is L, okay. The question itself, see, B, it should be C and A they have to ask, right? Because B velocity is 0. So that 0 is to half kinetic energy at B, so that will be 0 is to 1. But none of the options are showing like that, right? It's that you complete the half circle, reaching the topmost position B, the ratio. So they should ask then why they have given this C point. Correct, no? So I think there is some mistake in this question. Let us see just what is the explanation they have given. Apply energy conservation between A and B, half mv L square lowest point is equal to half mv h square plus mg into 2l. VL is equal to under root 5 gl. So VH is equal to 100 gl. There is mistake in this question, guys, okay? So he should not use this minimum horizontal velocity at the lowest point. There is a mistake in the question, okay? So you will get to know about it more when I teach you vertical approach. Let us see some more questions. Block of mass 100 kg slides over a distance of 10 meter on a horizontal surface. If the coefficient of friction between the surface is 0.4, then the work done against friction is. Please calculate quickly. Calculate work done by friction, then you put +1. Quickly, guys. In 10 seconds, it should be done. I am telling you, definitely similar questions will come in the exam. You can tell me after your exam.
4,000.
4,000, let us check. Yeah, correct answer. So anyone have doubt? Shall I explain this or shall I go ahead? Okay, no doubt. It's simple. Potential energy is gone. Okay, that I have not taught it. A bullet is fired into a fixed target, loses 1/3 of its velocity, traveling 4 centimeters. Where's the value? That I will teach later. The ratio of powers, that I will teach later. Power I have not taught you. Trip and the same current energy. To leave. At this also I will teach later. Yeah. So let us do this interesting theory based question. First, identify the correct statement from the following. First statement is work done by a man in lifting a bucket out of a well by a means of a rope tied to the bucket is negative. Correct or wrong? Correct or wrong? Such questions will come. Okay, there is a lot.
Is it correct?
See, let us see whether it is correct or not. So there is a well, okay, and there is a bucket, something like this, let us say, and something like this we pull, right? So if you see, they are asking work done by the man, right? By man. Well, so the force applied by the man, what is the direction? Downwards, right? So the same force is acting on this, and displacement is of this bucket is also up. So the work done is positive, not negative. Correct, right?
Yes, sir.
So it is never be negative. Okay. Work done by a man in lifting a bucket out of a well by means of a rope tied to the bucket is negative. No, it's wrong. But actually, the answer for A is 0 because he is not touching the bucket, right? I told you the displacement of point of application of the force. The man is not touching the bucket, so the work done is 0 for option A. Okay, guys? Everyone understanding what I'm trying to say? Shreta, Samita, Zavian, Samita.
Yes,
Yeah, if you're not understanding, tell me. I will teach it again. Second, can you tell me work done by gravitational force in lifting a bucket out of a well by a rope tied to the bucket is negative? Correct. Displacement is up, gravity is down. Negative. B is correct. C. Work done by friction on a body sliding down an inclined plane is positive. Wrong. Because if the body is sliding down, friction is up, displacement is down. Negative it is. Option C is wrong. D. Work done by an applied force on a body moving on a rough horizontal plane with uniform velocity is 0. See, they are saying work done by an applied force on a body moving on a rough horizontal plane with uniform velocity is 0. Uniform velocity means velocity is constant, right? Guys, what is the meaning of uniform velocity?
Acceleration is equal to 0.
Are you sure?
Yes, sir. Because the velocity is not changing with respect to time.
Okay. Anybody else want to comment on this? Okay, so uniform velocity means the velocity is not at all changing, its direction is fixed, its magnitude is fixed. So if the velocity is fixed, there is no change in kinetic energy, right? If there is no change in kinetic energy, no work is done. So they are saying work done by an applied force on a body moving in a horizontal and uniform is zero. Correct. D is correct, B is correct. E, work done by the air resistance on an oscillating pendulum is negative. What about E? B and D is correct. Now, E, tell me the option E. Let me show you this. So, on an oscillating pendulum. So, you guys have seen, right? If I take a pendulum and if I displace it little bit, so it oscillates like this, no? Correct? To and fro motion. But finally, it comes to rest. You know why? Because there is the air resistance which is stopping it. That means always the displacement of this bob and the air resistance are opposite. That's why it is stopping, right? Because it was moving like this, then the air resistance is like this. So displacement is in this direction and the air resistance is in this direction. So the work done is negative. Let us see. So B, D, and E. What it is saying, D is work done by an applied force on a body moving on a rough horizontal plane with uniform velocity is zero. It's correct only, no? Oh, it is saying B and E only. Let us see what is the explanation he has given D. Work statement wooden by friction. Bodies moving. The friction present which will act in the direction of that force. Friction will oppose the motion of the body, reducing its velocity. There is a net on the body will not be zero and force will the applied force will not cancel each other quickly. Applied force on a body moving on velocity is zero is incorrect. See what he's saying, if the body is moving on a rough horizontal plane, there will be friction present which will act in the opposite direction to the applied force. Correct. The force of friction will oppose the motion of the body, reducing its velocity. As a result, the net work done on the body will not be zero, as the force of friction and the applied force will not cancel each other out completely. Therefore, the statement D, work done by an applied force on a body moving on a rough horizontal plane with uniform velocity is zero, is incorrect. How many of you understood this? Guys, how many of you understood this? I will show you 1 second. What it is, very in-depth question. See, let us say there is a block, okay, which is moving with some velocity v, correct? Let us say some 10 meter per second. Is there any force acting in the horizontal direction, guys? Sayuta?
No, sir.
No. So the velocity is constant. Now let us say I will apply a force of 10 Newton. Okay. And a friction force of also 10 Newton. Correct? Let's say I will apply 10 Newton only. Now, let's say if this block moves a displacement of 2 meter, then the work done by the external force will be how much? 20, 10 into 2, that is 20 joule. Work done by friction is 10 into 2 with a minus sign, minus 20 joule. You can say, sir, total work done is 0. Correct? Why that option is not correct? So the twist is, if I keep one block on a rough plane, okay, there is a friction. What happens, like if I try to move it, okay, if I, let's say it's at rest, if I try to move this block, it will not move until unless I apply a force greater than friction. Okay, so for example, let us say I will apply some, let's say friction was my 10 Newton. Okay, now what I will do, I will apply a force of 10.00001. Okay, and it will start moving with v. Correct? It will start moving with some velocity, right? Now, since this force which I have applied on this rough surface to move this block has different value to achieve some velocity. Correct? So now the work done by that force is greater than 20 joule and work done by friction is equal to minus 20 joule. Now there is a difference and the work done is not 0. Total work done is non-zero. Okay, remember this. Whenever there is a uniform velocity on a rough surface, and if you are using any external force, then you have to push more than this 10 Newton. Still, if you want to maintain this velocity, if you don't apply force, you cannot move this block because friction is there. Okay, so this is a situation where you have to apply the external force more than this 10 Newton to maintain that velocity. Hence, the external force is more than friction, so there will be a net work done. It won't be 0. That's why option D is wrong. So the correct answer is B and D. Any doubt?
No, sir.
Okay. So a stone is projected at an angle of 30 degrees to the horizontal. The ratio of kinetic energy of the stone at a point of projection to its kinetic energy at the highest point of flight will be. See what he is asking. We are projecting a particle with velocity v 30-degree angle. Let's say point A. He is saying when it reaches the topmost point, you guys know this velocity will become only v cos 30 degrees, correct? So is asking, let's say this point is B, what is the kinetic energy at A, H2 kinetic energy at B. So at A, what it will be the kinetic energy? Half m v square. At B, what it will be? Half m into v cos 30 degree whole square. Half m v square got cancelled out. 1 by cos 30 whole square. Cos 30 is how much, guys? Root 3 by 2. So it will be 4 by 3. Okay, 4:3. So there is only one option, 4:2. Okay, guys. A ball is projected with a kinetic energy E at an angle of 60 degrees to the horizontal. The kinetic energy of this ball at the highest point of its flight is, in terms of E, you have to tell. Just now we seen, right? So there it was cos 30 degree, here it is cos 60. Cos 60 is 1 by 2. So the ratio becomes 4:1. So it will be E by 4. Okay. In 10 seconds, you can solve these questions. So this bullet questions I will teach you separately. Sand is being dropped from the stationary dropper at rate of this much and conversion pattern with the velocity of this much. The power, this question will teach later. Both are given a velocity v in opposite direction, then maximum elongation of the spring is this. I will teach later. So far, whatever I have taught, will cover these questions. Bullet questions. See, bullet questions are coming a lot. Body of mass 0.5 kg travels on a straight line path with velocity v is equal to this. The net work done by the force during its displacement from 0 to 2 is 0 to 2 is 0.5 kg 3x square plus 4. So again, see, simply 10-second question. So for force into displacement, you have to integrate, right? From 0 to 2. Okay, so 0 to 2, F is what? Mass into acceleration into dx. X is growing from 0 to 2. This will be work done. So mass is 0.5 kg given. Acceleration, if in terms of x is given, I told you v dv by dx into dx. Correct? Dx you cancel. So from here 0 to 2.5, velocity is how much? Velocity is 3x square plus 4. 3x square plus 4. So it is okay. Okay, so here velocity is 3x square first plus 4, right? V is equal to 3x square plus 4. I want to calculate acceleration. So acceleration is v dv by dx. Let us calculate 3x square plus 4 into differentiation of this is how much? 6x. Calculate 6x into this 18x cube plus 24x. Correct, guys? This is my acceleration. So 18 plus 24. So we have acceleration is equal to 18x cube plus 24x. Now, so my work done will be f dot dx 0 to 2. F is equal to mass into acceleration. This is my acceleration. Mass is 0.5, 1 by 2 I can write. 18x cube plus 24x dx. Integrate, guys. 1 by 2 I will take out. 18x cube means 8x to the power 4 by 4. 0 to 2 plus 24 into x square by 2. 0 to 2. Just substitute 1 by 2. 18 into x to the power 2 is 4. 2 to the power 4 is 16 by 4. Plus 24 into 4 by 2. 2 2s are 24, 2s are 48. 48, 4 4s are 18, 4s are 10, 4s are 48, 4s are 8, 4s are how much, guys? 32, right? 32 plus 40 is 72. This is 72. So finally 1 by 2 into 70, 110, 110, 112, 120. So you just 60 joule I am getting. Let us see what is the answer. 60 joule. Okay. So otherwise you can use simply like this. Work done is equal to change in kinetic energy. At x equal to 0 you calculate velocity. At x equal to 2 you calculate velocity. You can do like this also. Any method. So understood this question, guys?
Yes, sir.
Xavier, understood?
Yes.
Okay, all right. I think that's enough. Rest you can try it out. Okay. I'll see you in the next class. Okay, guys.
Okay, sir.
Bye.
sir.
Thank you, sir.
Thank you, sir.